Thank you for joining us on this webinar, which is focused on decarbonising public and commercial buildings. I'm Andrew Todd. I'm Sureserve's Head of Net Zero Carbon, and I'll be joined by Michael Firth, who's the Business Development Manager from Core Energy. Core Energy are one of Sureserve's businesses that focus on solutions for public and commercial buildings. And there's various other members of the Core Energy team on the line who will be helping out during the Q&A sessions. Great. So this is what we'll be covering today. We'll be talking a bit about Sureserve ourselves and then setting the context as to commercial and public buildings energy consumption. We'll then talk about decarbonisation solutions for those buildings and delving into best practice design, installation and aftercare for some of those solutions before rounding off with funding support and contracting mechanisms. And there should be plenty of time for questions at the end, so do come off camera and mic to ask your questions, or you can log them throughout the webinar on the Q&A function. We've also got a couple of polls where we want to hear your opinions on things, so please do take part in those when they come round. So briefly about Sureserve. So Sureserve are company working across compliance and energy services for the social housing and public building sectors. We're playing a key progressive role in decarbonisation and facilitating the energy transition. And as you can see from the map, we've got great coverage across Great Britain and deliver schemes in all areas. In terms of the key areas, so we cover building safety and compliance, covering the kind of big six across social housing and public buildings, and increasingly looking at instances of damp and mold, covering out checks that we're in the properties of, helping to spot and remediate issues early, and protecting building occupants against damp and mold issues. And then on the energy services side, we're leading building portfolio owners on their decarbonisation journeys, typically from a start position of predominantly fossil fueled heating to fully decarbonised building stocks. That involves looking at their data, understanding the condition that the stock is in, then developing long-term programs of retrofit that identify fabric opportunities, opportunities for renewables, and then, of course, monitoring buildings pre and post retrofit just to see that they've delivered on what they'd intended to. In terms of some of the numbers of the installs that we're doing for energy services, these show the data from 2024. We're delivering energy efficiency and renewable energy measures across all of the main government grant funds, including the public sector decarbonisation scheme, which is most relevant to this webinar. And we're also gearing up to do many more in 2025 under the Warm Homes funds. And we've got the full set of accreditations to deliver across all of these schemes. So setting the context then of carbon emissions from non-domestic and public buildings, there's just under 1.8 million non-domestic buildings in England and Wales. And these are broken down by the number of buildings and floor areas on the main categories that you can see on the top right of the slide. In terms of energy use, non-domestic buildings, they consume about 156 terawatt hours of gas and 122 terawatt hours of electricity per year, which is the equivalent energy consumption of heating 1.3 million homes for a year and powering all the UK's homes for a year and a half. So pretty significant when it comes to the overall picture of energy consumption from non-domestic buildings. And when you break it down by sector, you can see that on an absolute basis, factories have the highest electricity consumption across all these different sectors, followed by offices, shops, and warehouses. But if you look at the absolute, switching from an absolute to an intensity metric, where you're looking at electricity consumed per meter squared of floor area, this means that hospitality is the most energy or electricity intensive sector, followed by shops and healthcare. Moving on then to looking at gas. Again, from an absolute perspective, it looks like factories are the most consuming, but on an energy intensivity metric, shops and healthcare are the most energy intensive. If we just focus quickly on the NHS, which, as we've just seen, is one of the most energy intensive sectors, there's NHS targets and plans in place to reduce emissions from both its carbon footprint, and these are the emissions that it controls directly, and its wider carbon footprint plus, which are the emissions that it has an influence over. And these are really challenging targets. And in order to move towards net zero by 2040 across its carbon footprint, we know that work needs to happen across all NHS estates to improve energy efficiency, to generate renewable energy, and to generate clean heating. We should now have the first of our polls launching, so please do keep an eye out for that and take part. And I will just check the results of those. So let me just see how things are going. We've asked what's the most urgent and impactful technology project across solar PV, EV charging, battery energy storage, heat pumps, building fabric. And in terms of results, these should now be published to you as the audience. I'll now pass over to Michael, who's going to lead us through some of the different solutions for decarbonising public buildings. Michael, over to you.
Many thanks, Andrew, and thanks everyone for joining us again today. I'm Michael Firth. I work in the business development team here at Core Energy. I've worked in the energy solutions sector for around about 12 years, helping some of the largest energy users, both public and private sector, look at routes to decentralise and decarbonise their sites through a range of different technology, some of which we'll come on to speak around today, as well as fielding some questions and giving a good overview of what it takes, what position you need to be in, and what strategic mindset you need to adopt to move forward into decarbonisation and achieve those energy goals and energy strategies. The first slide we're going to talk around is something, and I apologise if there's people on the call that I've spoke to on a one-to-one basis. This is what primarily will make up your decarbonisation journey. People have heard me talk about this in great detail before and really stress the importance. But if your business, your organisation, if you're looking to decarbonise your sites, if you're looking to go on a net zero transition, the first thing that your business needs to adopt is a net zero roadmap and a decarbonisation roadmap. You need to be able to successfully map out how you're going to get there on your journey and what steps and route you need to take to make it possible. Without doing so, you will find many pitfalls along the way. And what that roadmap should tell you is you should be able to measure whereabouts you are now from both a carbon and a cost perspective. So we can see where we are, and we also need to look at how we're going to get to where we want to be. Through doing so, we can then phase the projects in an approach that gives your business the best results for you in particular, because everyone's road to decarbonisation is vastly different, and we all hit different drivers along the way. Some will be solely focused on carbon, some will have a mixture of carbon and cost, what we need to achieve. And being open and honest, we know that some of the projects and the individual solutions that we speak about probably don't give a clear return on investment as others. And it's important to try and change that mindset around that individual projects should be used to support each other, both from a carbon and a cost perspective, to again achieve those best results. And the mindset should be around not what does this individual project offer in terms of financial payback, but what does this full solution offer? If I mix solar PV with battery storage, with heat pump, what is the combined return on investment? What is the combined carbon saving? And by adopting that full solutions mindset and that overall roadmap, we'll see you achieve those best results. And as mentioned, every individual roadmap is completely different business to business. based on drivers, based on site suitability, based on technology. Some customers will want to lead with on-site generation, such as solar PV, wind, maybe even still a little bit of CHP to release extra cash savings. Some businesses will want to start decarbonising heat or go for more low-hanging fruit first. And it's important that we measure each step along the way. We understand where we are, we understand where we want to get to, and we understand the steps needed and what impact each individual project will have on that full route to net zero, that full route to decarbonisation. What we're going to come on to now is talk about a little bit about the individual solutions. Before we do so, I think we've got the second poll to share with you. Andrew?
Yeah, so that poll should be launched now. So we're asking, what are the stopping or what's stopping you or slowing progress with these projects? Is it funding, an understanding of the journey, having a trusted delivery partner, or is it other internal issues? And those should be published. Should be now displayed to you, so you should be able to see those results. Thanks, Michael.
Thanks, Andrew. So what we're seeing there is majority of the audience looking at funding as a roadblocker. Also a couple of results for understanding the journey, having a trusted delivery partner, and an internal resource. So hopefully as we work through these next slides, we'll start answering some of those and start looking at we can unlock those barriers as we move through. So looking at individual solutions, individual technologies, and how they may best benefit your business. The first one we're going to discuss is solar PV. One that's always at the forefront of every business's mind, one that gets the biggest coverage, and one that we do see a lot of people, a lot of organizations leading with. So solar PV or on-site generation, what is it? It's a means of generating your own power on site from a fully renewable source. We know that the grid is decarbonising, and as a nation, we are doing a good job of decarbonising our power supply. That being said, over 50% of our electricity is still generated from gas power, and what that gives us is open to market volatility. The big thing we're seeing around solar PV at the moment is obviously coming off grid and decentralising, removing a large percentage of your site's energy consumption away from that volatile and variable grid price. We hear a lot of people, and when I engage with clients, we hear a lot talking about return on investment, expected payback periods. And again, people may have heard me speak about this previously, but the mindset that we need to try and adopt when thinking about solar PV and understanding the market volatility in terms of grid pricing is what solar PV will give you is a 25 to 30 year asset that removes a large percentage away from that grid pricing. A return on investment is merely a picture in time. The sales journey from concept through to delivery on a solar PV project and any on-site generation is typically between 6 to 9 months. If we were to calculate a return on investment based on your grid pricing as of now, where we'd be in 9 months' time when the asset actually got deployed could be a far different place. It may show a greater payback. It may show a longer payback. But it's important to acknowledge that what the solar PV gives you is a long-term security of supply against that grid pricing, and look at actually the levelized cost of the energy for what the solar is going to produce. And understand that for the next 25, 30 years, as said, that is what you'll be paying for your power, not comparing against grid price, because we know it's so changeable. And that's where we need to look at. And what solar PV is, it's about utilizing space on site and getting the most out of assets that are sitting there, such as roof. We could also look at solar carports, which are now becoming more and more popular. Obviously, the cost to install is far greater, but again, it's about utilizing space. And then we have ground mount systems as well. Again, looking at occupying space that is previously unutilized, and again, monetizing that for the best of your business. We're now seeing battery storage become a commercially viable option, And the big thing about battery is obviously understanding what your business case and what your business's business case is around that battery storage. What would you like to use it for, and where do you see the best commercial application? And from that, you will get the best returns. Do you want to use a battery to store curtailment from the solar PV to then use on site in times of peak demand? Do you want a battery storage to play grid response markets, again, generating revenue? Once the energy services supplier understands that, they can give you a better business case and a better understanding on exactly how that battery will work in combination with solar or in combination with the wider technologies. So what do we see with solar PV, and how do we assess? First of all, if we're looking at a roof mount, obviously we need to know that roof's in good structural condition. One of the biggest pitfalls we find when carrying out solar PV installs is obviously the condition of the roof and making sure it's able to be load bearing and in good structural condition to take the increased load that solar PV system will deploy. Ideally, we should be south or east facing to generate the greater yield, an optimal panel angle of 35 to 40 degrees, and we don't want to go into an unnecessary shading. Good accessibility should be provided so we can carry out regular installation and maintenance checks. The benefits, as we've already mentioned, it will reduce your electricity costs, and you've got security of energy supply, as well as reducing your CO2 and giving you that form of renewable generation on site. It'll increase the property value and a financial business case. Key consideration is, how does it fit with your financial drivers, the current and future electrical load, grant and financing available, site suitability, and obviously the maintenance budget as well for the ongoing O&M and the inverter replacement as required. So at Core Energy, we have a good tradition of solar PV installs. Just one of our installs that we've carried out, Norfolk District Council. This was a swimming pool support fund from a grant. The size of the PV, 240 kilowatt peaks and 512 panels were installed, generating 188,000 kilowatt hours per year, so equivalent to powering 70 homes. What that gives the North District Council is they now know for the next 25 to 30 years, they're going to get an annual generation from a renewable supply of 188,000 kilowatt hours, taking a large percentage of their site away from grid pricing and giving them that renewable form of generation. Solar carports. So we have completed solar carports. This is for York St John's University, part of the public sector decarbonisation scheme. It's a PV size of 137 kilowatt peak and 360 panels. We've also combined this with battery storage of 312 kilowatt hours to capture the curtailment and use on site in times of peak demand. Again, showing and utilising how the two solutions can be complementary each other in a real world setting. Our next product or solution that we're going to come on to talk about is heat pumps and renewable heat sources. Suitable for most commercial property and locations, air source heat pumps are there to displace your gas consumption on site and better support your decarbonisation journey. What we are seeing at the moment is air source heat pump seems to be the main or the preferred technology as we're looking at these heat pump solutions. Ground source obviously comes with further increased capital expenditure due to the need for civils works and obviously expensive drilling conditions. Shared ground loops are an option for an energy centre and a heat network setting. And again, we can also look at deploying water source heat pumps should your site be located next to a suitable body of water. The benefits of heat pumps is we can reduce your heating and hot water costs. High energy efficiency of greater than 300% can be utilised in certain circumstances. And what we want to see from a heat pump and a heat pump deployment is really maximising what we call the seasonal coefficient of performance, or you may hear that it's referred to as SCOP or just COP. And that is how many kilowatts of electricity do you need to get a set amount of kilowatts out of the heat pump. So typically we can operate this COP above 3, and we want to utilise a good flow temperature around about 65 degrees to get so. It will significantly decarbonise your heating and heat load and your hot water, and again increase your property value, and financial business cases can be assessed. The key considerations are your current energy costs, electrical cooling and heating loads. Is there grant finance available, site suitability, and again, coming on to the maintenance budget. So a couple of case studies from projects we've already completed, one being the M&S Bank Convention Centre in Liverpool City. Again, this was done on the public sector decarbonisation, and this is a 200 kilowatt air source heat pump replacing the gas-fired hot water system. We also included a smart thermal storage, or you may refers to as a buffer vessel, of up to 8,000 litres to give him built-in contingency and flexible operation. We also carried out LED lighting upgrades of over 16,000 fittings, and the air source heat pump has reduced energy by 75% and carbon by 83%. So a significant impact on the arena's decarbonisation and taking them towards that net zero. We also completed work for Widnes Viking Stadium. Again, this was done from the PSDS, and we installed 14 air source heat pumps in the southwest and north stand, replacing 3 gas boilers and 4 gas water heaters. Specialist acoustic solutions to reduce noise and a saving of 136 tonnes of CO2 per year. So yeah, we're going to talk to best practice design, installation and aftercare. So when we're designing our solar PV, it's important to design the size of the system to your current or planned future base load. What we don't want to do is oversize the system and be exporting valuable generation to grid, where the payments from grid can be a lot lower than offsetting actual demand. So all system sizes all systems will be sized in conjunction with the site, understanding your site load, your site profile, and designing a system that's right for your site, as opposed to just maximizing roof space. We have full safety issues, and safety always comes first in any install that we're doing. And we use high quality products that are matched by 20-year warranty on the inverters and mountings and 25-year performance warranties on the solar panels, aiming for the highest ROI across a lifetime. In terms of compliance, full specific guidelines of the building insurers are met to, and all access safety systems are designed in line with CDM, and complete reporting routes to PSDS, should we be looking for funding applications, are completed. Systems are always designed with operation and maintenance and ease of maintenance in mind, and that we do so we're not itching any further issues as we move forward. And then we complete 365 days a year, 24/7 remote monitoring, so we can understand the output of the asset and understand the output of the solar PV panels. So an effective aftercare, 79 to 90% of solar PV system components are open to the elements, as we all know, and individual components will not last long as a system lifestyle. These include inverters, strings, etc. Cables and connections need to be checked and tested annually, and checked for vermin and nesting birds, and soiling can affect performance by 20-30%. So it's important that we carry out regular cleans. Certainly in coastal or dusty areas, regular cleaning is scheduled as required, and we can flex the O&M contract to each individual client. So the installation checklist would include a site survey, a DNO application, full structural surveys, site mobilisation, electrical infrastructure, commission and handover. So we can offer full turnkey solutions right from concept all the way through to delivery and ongoing operation and maintenance. If we can look at funding and contract options, again, we spoke around these in the polls. So we have the good old-fashioned capital expenditure, where the client comes out to us and wants to own and operate the system themselves. They want to take the financial risk. They want to get the investment. They want to get the greatest returns. So we offer capital expenditure as standard. We can also then look to tie into external funding, and these may take the methods of power purchase agreements, which are the end client basically pays for the energy generated at a set pence per kilowatt rate. And these come in many different formats. Some are escalator linked, so the price you pay on day one is lower than the price you pay on the end of the funding agreement, and some are completely fixed for the length of the funding term. And again, these can be flexed for what's right for the client, what's right for the site, what's right for their business needs, and they can be flexed over time to 10, 15, 20 or 25 years, dependent on your business. As we demonstrated on the case studies, we also have experience and knowledge of all government grants, such as public sector decarbonisation scheme and the recent NEEF funding that were released pre-Christmas and is now closed for applications for next year. So we are able to assist in full feasibility, full design, and also full applications for any government grants moving forward. And the contracting mechanisms, a traditional model, employed consultancy, design, and the contract delivery, or the preferred route is full turnkey, where we, as mentioned, we take it all the way through concept, all the way through into operation and maintenance and commissioning and handover. That's it for the slides that we have to go through. I think we're going to hand over to audience Q&A. Thanks ever so much for your time. I hope you found some useful points in the slides and the discussion. But look forward to getting any questions and hopefully answering them and providing some more clarity. Thank you.
Brilliant. Thanks, Michael. Yes, as he said, please do come and ask your questions. You can either just come off mute, come on camera, or you can log them in the attendee questions function. We do have a couple of questions to kick us off. So we'll start with, what are the first steps organisations should take when starting their decarbonisation journey?
Again, I think the first steps, and again, as mentioned, is that an organisation should one look at where they are now, in terms of where are they producing the carbon, where are they consuming the carbon, and what their current situation is. It's from then analysing it and understanding how they want to plot out the route and where do they want to get to, and continuing to measure that. So understanding, if we do solar PV, what is going to be the impact on our business? If we were to do a heat pump project, what would be the impact? If we were to transition to electrified fleet, say understanding the full scope 1, scope 2, scope 3 emissions is the first port of call, and understanding how their business, how their buildings are operating as of today, and then speaking to a trusted consultant and understanding the impact of each operation, each project, each solution, and how that will best benefit their business as they move to decarbonisation, and then road mapping them out to give the best delivery for their drivers.
Yeah, so it sounds like having a coherent plan at the start of that journey is a critical part of it, not just diving into individual projects without thinking about the whole impact and their emissions over time.
No, it's absolutely right. What good looks like and where we want to get to is, so all the solutions are working together as an ecosystem. So your solar PV is feeding into your heat pumps, your batteries on standby to use the curtailment, EV chargers are linked into solar carports. It's about doing the full ecosystem, and you can't do that if you just take a project by project view. You'll fall down. It needs to be understood that this is what we do, this is going to be the impact, this is how we move on to the next opportunity.
Yeah, brilliant. In terms of funding, so we talked about some of the funding mechanisms there, and I suppose having a forward plan will really help to understand when you can draw down funding for different types of projects. But what could you expand on that a little bit in terms of different funding mechanisms and how organizations could approach bringing in external funding?
Yeah, and I think you can split this out pretty much by the public and private sector. So we know if we take the public sector, for example, the big funding scheme that we're looking at the moment is the public sector decarbonisation scheme, open to public bodies. Now we know that the application window is open once a year, usually around September, October time, with results then published around about the following springtime. But to get to a point of having a viable application, there's a lot of pre-work what needs to be required in terms of feasibility, in terms of design, in terms of costing, again linking into potential roadmaps to understand this is the projects we need to submit for this application. So as we look for that, we're talking about a September, October window to apply. Ideally, organisations need to be start engaging with suppliers, engaging with trusted contractors, roundabout now, if we're being totally honest, to start doing the roadmap planning, the analysis of the data, do the qualification to understand what projects could be suitable, and then start doing that detailed design to get ready for that application. And it's important because the rules on the grant funding and the acceptance process is quite strict, is quite stringent. And if we don't do the upfront work, we don't do the feasibility, we don't do the design in enough time and enough space, then the application will fall down and you will miss that window. So it is important to start having those conversations now. Start understanding what projects are urgent, what projects are actually viable, and start building up that business case and design to take you to a viable PSDS application.
Brilliant. Thanks, Michael. Do we have any other audience questions? We've got one from Susan. So Susan May from Urban Design Learning, Head of Housing Design. So she's asking, it looks like the overall annual saving to energy cost for PV will be low, taking into account that the installation life has to be renewed after only 25 years and the maintenance regime needed. Can you give more examples of the annual net saving?
It's difficult to give examples without actually looking at the site and understanding. We are seeing, to put it in perspective, we are seeing return on investment and payback periods anything ranging from 4 to 6 years at the moment in the solar PV sphere. We have been for the last 18 to 24 months where panel pricing has decreased and a steady capital cost, but energy pricing has increased, and we're at a bit of a crossroads where we are seeing, paybacks certainly under 5 years for roof-mounted systems. Obviously, carport and ground a little bit more increased. That's simply because the increase in civil, the increase in structural costs. But roof-mounted systems, we are seeing typical payback periods now under 5 years. And again, obviously a site up in the north of Scotland probably won't give a good payback as a site down in the south of Cornwall, simply because there's more daylight hours and the irradiation of the sun's far greater. But again, business cases can be assessed, and we're looking at a standard 5-year payback at the moment.
Yeah, so it's a pretty good business case stacking up for solar PV.
Yeah.
Just to try and add to that, it's probably in terms of the actual saving, as Mick said, because it's site specific based on that site's load and the current cost. It's hard to try and give a number. It's all down to what you're consuming on that particular site, and what you've got to generate from your PV, and unfortunately, it's individual. We've seen sites that cover well in excess of 50% of their consumption, their self-sufficiency, as it's called, how much of that energy they're using on site that is generated by the PV, well in excess of 50%. But if you have, a huge roof and a low load, obviously that could be, it could be massive, but then it would be cost prohibitive, as the attendee suggested. And it's about then making the PV an appropriate size for the load and therefore the current cost on that facility. Obviously, if you've got a high load and a small roof, unless you look at some sort of ground mount or carport solution to increase the solar capacity, you're always going to have a limited self-sufficiency or a limited amount of power that can be generated by your PV, just because of the physical constraints of your building.
Yeah, brilliant. Thank you, Darren. I've got another question. So what are the biggest installation challenges when deploying heat pumps or solar PV at scale?
Again, when we look at installation channels or challenges, you can split out the technical and the commercial. So there's two options, two different sectors. Technical wise, certainly to look at solar PV, as mentioned previously, it is the roof suitability, it is the placement of the panels. We're also seeing grid applications, so DNO can cause slight issues, but again, it's about us managing that. It's about us working with the client and working with the DNO to mitigate those risks. But certainly with PV, again, we'll say these are the issues now. We've been saying them for the last 10 years, and we'll say them for the next 10 years. It's the roof suitability, and it is the grid conditions. Heat pumps, again, technical issues, looking at around the location, the siting, the flow temperatures, making sure your heat pump is right for your business. Your heat load would your heat load benefit from a heat pump, and what percentage of the heat load could that heat pump offset? And again, looking at what we class as your MIC or your maximum import capacity, understanding is a heat pump and the increased load actually doable on your site? Is it going to come out? Or is it going to come out with increased grid costs? They're certainly the technical aspects. And again, from a commercial aspect, it is all about balancing the cost of carbon with the return on investment. And that's why we like to say it's important to have that full solution mindset that, yes, the solar PV may give a 5-year payback. The heat pump might be maybe a 9-10-year payback. But when you combine the two, look at the aggregated cost is the best way to look at these, because you're doing them as a decarbonisation journey, not as individual projects.
Yeah, brilliant. We've got a question from Alex Thomas at Bosch. Hi, Alex. So he's asking more about the DNO. Is there a process for applying or contesting the DNO for electricity provision for heat pumps? There's been some cases where they've had to revert back to gas because the electricity supply is not enough. And then there's a follow-up question about thoughts on hybrid heat pumps to build in resilience.
So looking at the first one, it's a good question, and as previously mentioned, it is a frustration that as a country, as businesses and organisations, we're looking to decarbonise, we're looking to go on that net zero, we're looking to do what's right and remove ourselves from gas. But as a nation and as a grid, we're perhaps not there to adopt that as yet. Now we are seeing grid reform come into place, and we are seeing the grid take good steps to start supporting. But as mentioned, it is a concern that unfortunately in some sites there won't be the capacity there to move towards large scale heat pump deployment, and these may be 2 or 3 years away, or it may come with an increased cost for the DNO to increase that capacity. And again, it's important to do that as part of a first qualification phase before you get too involved with the projects. And that's important, to look at with a solutions provider that can help you do that and quickly rule in a project. Is it viable technically or isn't it? Again, before too much cost has been expunged. Hybrid heat pumps, they are an option. I have seen these deployed personally, where you use a heat pump to get you up to that 65 degrees, and then you use a gas boiler sometimes to take you that little bit further. It does offset a large percentage of gas consumption. Obviously, we want to be in a position technology-wise where we can get a heat pump to take us all the way to the temperature required, but we are still pigeonholed a little bit by the temperatures available from heat pumps. But yeah, it is an option. We see it used certainly in industrial setting, where industries are looking at producing steam. A heat pump can't produce steam. We have to be honest about that. But we do see heat pumps in industrial settings taking you up to 65, 70 degrees, high temperature heat pumps, perhaps taking a little bit higher than the boilers kicking in and just getting you up to that steam temperature or higher temperature where required. So yeah, they are a viable option. And yeah, they do still offset a large percentage of gas load.
Brilliant. Keep any questions coming through. Just a kind of follow-up point from me on the DNO application. The scale of the heat pump projects and the solar PV projects that you're working on at Core Energy, does that mean that you're making DNO applications way in advance of the detailed project design and any installation, compared to some domestic scale projects where you might be doing the DNO application retrospectively after install? Is that right, Michael?
Yeah, so we'd always do the DNO application as early as possible when we first start getting into those contractual terms, simply because, again, we want to get the critical path and the highest risk point mitigated before we move into, again, carrying out any detailed designs or further costs. So we'd always look to do that DNO and the planning, if required, as early as possible to make sure we've got the consent to connect the asset ultimately, again, before we went into construction. I don't think I've ever heard in, like say, 12, 13 years of doing this role of any site deploying an asset without grid application. The risk is just too great. So grid applications are always done as a primary.
Brilliant. Do we have any final audience questions coming through?
If not, just jumping back a couple of questions. I know that they've been focused on solar and heat pumps, especially in the private sector. Jumping from a gas-based heating system into a heat pump isn't always the right solution, and that's why we take the consultative approach that we do. Sometimes it's about prioritizing other areas, or actually looking at a CHP or something to give you some savings in the relatively short term to help fund a move to a full heat pump solution in the fullness of time, because the jump sometimes is cost prohibitive. And that's, as Mick has talked about during the session, that's why having an overarching plan, and understanding what you're going to do, when and why, and what it's going to ultimately give you is quite important, because it's not always, the heat pump and that being the right solution.
Yeah, definitely. Absolutely right, Darren. It's there's a lot more strands to decarbonisation and net zero than I think you first realise, and it's balancing, like you say, that financial impact with the carbon savings, and understand how you can release those funds, understand how you can generate capital to ultimately pay for the projects as you move forward. And that's why that roadmap that I first spoke about is so important. And sitting down with somebody like Core Energy and mapping it all out, it is really that route to success.
We see it especially where people have got leased buildings, where they've got a lease, or we've actually got a client at the minute that plans to demolish the building in 2030 earlies, but they've got a huge saving that could be made. Unfortunately, the time scale doesn't warrant the investment up front. So actually there, we're looking at a lease for a CHP where they haven't got the front end cost, and then strip the asset out. Literally, they'll pay for, we're looking at a 5-year lease term. So the asset can go in, they'll get 5 years of the savings, and at the end of it, we'll just take the asset back out. So again, there's lots of different ways that we can help people. Unfortunately, again, it is site and client specific. So you have to have that conversation and understand the individual situation.
Yeah, it's brilliant. You have to sometimes get creative, and it really helps to talk to the experts who have been through all of these different types of cases, use cases, commercial and technical.
No two are the same.
Yeah, exactly. Well, brilliant. Thank you for that. I think that's the last of the audience Q&A coming through. So just wanted to say thank you to the audience. Thanks for taking part. If you wanted to continue the conversations, then do reach out to one of us here at Sureserve. The team at Core Energy definitely there to help on your PSDS journey, and with all of the planning towards decarbonising your public and commercial buildings. So yeah, just say thank you to the Core team, Darren, Michael, and thank you all for joining us.